So proceeding on to the next question, that is your question number 11. Two flask P and Q contain an ideal gas and are connected with a tube of negligible volume compared to the flask. Okay, so the volume of P is twice the volume of Q. Okay, so that means if the volume of Q be V, so that means the volume of P will be equal to your 2V. Okay, the P is held at a temperature of 200 Kelvin. Okay, so that means over here P is held at a temperature of how much? 200 Kelvin. Okay, and Q is held at a temperature of how much? 400 Kelvin. Okay, so we need to find the mass of the gas in P divided by the mass of the gas in Q. So in this question, let the pressure in the first flux, that is flux P, so this be pressure be P1. Okay, and the pressure at the second flux, that is flux Q, suppose the pressure at the second flux, that is flux Q, is P2. Okay, so these are the pressures. Okay, P2. Okay, so as the two flux P and Q are connected, I can say that pressure will be equal in the both flux. So P1 should be equal to your P2. Okay, so these are our equations for volume. Okay, and these are our equations for temperature, not equations, parameters. Okay, so over here for the flux P, okay, suppose this is the flux P, I can write that P1 V1 is equal to nR T1, right? N1 R T1. Okay, so what is pressure? Pressure is P1, right? What is volume? Volume of the flux Q, volume of the flux P, so the volume of the flux P is 2V, right? So this is equal to your 2V. What is the number of moles? N1. Okay, R is the universal gas constant and T1 is the temperature. What is the temperature of the flux P? 200 Kelvin, right? 200. Okay, again for the flux Q, I can write that. So this is the flux Q. So I can write that P2V2 is equal to your N2RT2. Okay, so what is the pressure of the flux Q? The pressure of the flux Q is how much? P2, right? So that means P2. What is the volume of the flux Q? The volume of the flux Q is how much? V, right? Volume of the flux Q is V. So what is the number of moles in the flux Q? So flux Q number of moles is your N2. Okay, universal gas constant is R and your temperature of the flux Q is how much? 400 Kelvin given. Okay, so that means this will be equal to your 400. Okay, so let us suppose this is our equation 1 and let us suppose this are our equation 2. Now if I just divide these two equations, what will we get? P1 into 2V divided by your P2 into V. So this will be equal to your N1R into 200 divided by N2R into 400. Okay, so over here I can write that this will be equal to your twice of P1 by P2. So this will be equal to your N1 divided by your twice of N2. Okay, and we know that since the flux are connected, what will happen? The pressure will be equal. So that means P1 should be equal to your P2, right? So that means over here I can write that 2 equal to, since P1 and P2 are same, 2 equal to your N1 by twice of N2. Okay, so from here we get that. So from here we get that N1 by N2, this ratio is how much? 4. Now what is N1? N1 is the number of moles in the flux P and N2 is the number of moles in the flux Q. Okay, so we know that N1 by N2, this ratio is nothing but also equal to the mass ratio, right? So that means the mass of the gas in flux 1 divided by mass of the gas in flux 2. Okay, so this will be equal to your M1 by M2. So this will be equal to your 4. So that means the mass of the gas in flux P divided by mass of the gas in flux Q. So this will be equal to your 4. So the correct option to your question number 11 is option C, 4. I hope you got the question.